have strings that extend over multiple lines and include a new line character. So if you have to include a whole paragraph of text or a template for a file, you would use this notation. Then operations we can do on the basic types. It's probably what you expect. So you have the arithmetical operators, plus, minus, divide. Double star is using for exponentiation, so raising a number to a power. Arrows are for bit shift, right and left. Logical operators do not use mathematical symbols, but instead they use plain English words, and or not. Then there are comparison operators, greater than, less than, less or equal, etc. And this is equality, so 2 equals for testing equality, and band equal for not equal to. Okay, now 2 to the 38. How much is that?
Can I calculate it?
You must calculate it with pi.
You want to do it by memory? If you're able,
Yeah, that's what I'm wondering.
But your phone doesn't work,
It's for a recording, so I'm recording the session, and anyways I leave at 2 p.m. so I will not be there for later.
Because it's been I can put the sound, but the video I can.
Little bit. If you can just turn a little bit, then it should be okay. I know it's a pain, but there are people in Portugal waiting for the Hangout session to be online. So.
What does capital L stand for? What does capital L stand for?
Yes, good question. We'll comment that. So everybody knows how much 2 to the 38 is?
It's a long number.
It's a long number indeed. Okay, so the thing is simple, just use the exponentiation operator and you get your result. Okay, now let's do this. This, as you might guess, this gives puts this number into this variable. But now we square that number again. So 2 to the 38 needs 38 bits to be represented. And this squared needs 38 times 2, so 76 bits to be represented. And this is a 64-bit machine. So you cannot fit a 76-bit number into a 64-bit register, location. So here you have an indication, the L. So L means that Python switched from native number, so something that fits into the 64-bit registers of your processor, to what is called a big num. So a larger number that does exceed the precision provided by the processor and must be calculated in software. So you must use software routines to do operations in this number. So this is called the long type in Python, so that's why the L. The switch happens automatically, you have to do nothing about it, but the L is just to remind you that this is going to be slower, because you can no longer delegate all operations to the processor.
For example, like Notice L, just number without L.
You just have one.
Yeah, I think it depends on your distribution.
Okay, that's weird. But just try to increase that, and at some point you will get the L.
No.
You're running Python 3?
Yes.
Okay. Okay, that's another difference between Python 2 and Python 3. So in Python 3, there's no longer the distinction between the two types. In Python 3, you are not reminded where you exceed machine precision.
All our exercises and tests are done with Python 2.7 or less. So it's all that if you follow.
No,
you may encounter some of these.
But it's good, so we know when to point out these things. This we should note down. Okay, but then let's make another test. So this is a floating point number. Okay? And I can exponentiate a floating point number using the same operators. Fine. Okay, now let's run this. So again, this number, and I get usual floating point representation as scientific notation, Montes sign exponent. Good. And then let's do this instead. Still works.
Still alive.
And keep increasing. Whereas okay, so this would be unreadable, but you see the difference. So floating point numbers never switch to a big number representation. So at some point you exceed the capability of the mathematical processing unit, the floating point, the processing unit on the processor, and then you're out of luck, numerical result out of range. This never happens with integers. Questions? We've already seen that operators can be overloaded, so the plus sign works as addition on numbers and works as concatenation on strings. So you can concatenate two strings using the plus operator. We all know that multiplication is a shortcut for adding something many times, and Python is consistent with that, in that you can multiply a string by a number and you just get repetition of that string. So a times 2 is AA. And order is not important in this case. But you cannot divide a string by a number.
Yes, foreign is.
So not all operators make sense in strings or other contexts. One operator that also does is this. So percent is used as in C or Java or other languages, used to compute the remainder of integer division. So the remainder of dividing 9 by 2 is 1, modulo operator. But this has also meaning with strings, and this operator is used for string interpolation. This means you provide a template string on the left, and your percent operator, and then values to be substituted into this. And where are these values substituted? Where percent letter code is found in the string. If you are familiar with C or C++, this is the same format used as in the printf statement in C. So %d means insert an integer number here, signed integer number. So here's the first integer number, it goes in this place. So 11. 32 goes in the second place. Now things get more complicated with floats, in that %f means floating, insert a floating point number here, but you can have a format specifier, and this means allow 1 digit after the decimal comma. Again, the complete specification is here, but if you're familiar with C, it's exactly the same format. %s is for strings. So insert a string here. So in this third template, we see that we have a string, integer, integer. And that's what we provide on the right side of the %. Okay, sorry, I had the highlight of the thing, so I should not indicate. Okay. And moving forward, so what we have seen so far, what we have typed so far at the prompt are expressions. Expressions are combinations of operations that return the result. So whenever you type something at the prompt that gives you a result, that's an expression. Not everything you type to Python is an expression. So not everything returns a meaningful result. And the exception that comes to mind for those who are familiar with C or Java is assignment. So assignment does not return a value. So you cannot you see, nothing is printed after that. So there's no value returned, so you cannot use assignment in for, while clauses, etc., as is normally done in C or in similar languages. There are the usual shortcut operators for assignment. Plus equal means add this to the left, minus equal subtract from the left, etc. Think of them just in this way. Actually, this form, so let's say you should really think that that plus equal A plus equal B is a shorthand for this, because this form will give you less surprises in Python. So that's a key difference with C and derived languages, and we will cover that. Questions? Okay, so what's the key difference here? In C or similar languages, variables are locations of memory. So you allocate space somewhere in the memory and then you copy that as there. That's not what happens in Python. So in Python, variables are just names you give to values. So when two variables refer to the same string, they actually means that you refer to this hello string by two different names, but the underlying value is the same. So you are not copying this string into two different locations in memory. You are just saying to the interpreter, I want to refer to the hello string by this name or this name. A bit like pointers. except we don't have pointer arithmetic. And then there is the is operator that allows you to tell when two variables are names for the same object. So the canonical example here would be this. So A and B are two names for the same object, and then the is operator returns true. So then say A is 1 and B is 1. And what's your forecast for this? Should be false.
It's not the same object.
It's not the same object.
But no, it's the same value, it will be true.
Same value, but the preference.
Yeah. But it will be true.
Why would it be true?
It was true, but it's something weird, basically.
I remember when I did it, it was true, how I remember.
Okay, so
It is true.
because
But
not
it's
the
more
same
efficient.
object.
Yeah, it's not the same object, but it's
I mean, you don't care if it's different object, you just care it's one.
Yeah, it just gets so in memory. I guess
No.
it's
Yeah.
The reason is that Python is caching small numbers. So in this case, they basically end up being the same number in memory because the Python interpreter already has the value 1 somewhere and just points you
If you
there.
create two complex objects, they shouldn't be with the same values. They should be different.